everyone, we're going to find the limit and use Hopital's rule where the limit as x approaches infinity of the quantity of e to the power of x plus x, all raised to the power of 1 divided by x. So let's see what form we have. It's infinity. So this one has this form here, the indeterminate form, infinity to the 0 power. So we want to write it in a form that helps us use L'Hopital's rule by taking the derivative of the numerator and the denominator. And then we're going to use this formula here. So basically what we want to do is set this to y. The formula is f of x, so you can set it to y or f of x, but I'm going to use y. So your y equals e to the power of x plus x to the power of 1 divided by x. Now, at this stage, what you want to do is take the natural log of both sides of the equation. So you have ln of y equals, and I'm going to go ahead and use this, the power property, and move this in front. And this is going to be ln of e to the x plus x. And next thing I'm going to do is go ahead, so I can get a common denominator and such, that 1 divided by x, I'm just going to put that like that. All right. So basically what we're doing is we're taking the limit as x approaches infinity of ln of y. So we're going to get that limit. And that's why we're going to have to use the formula at the very end. And this equals the limit as x approaches infinity of ln e to the power of x plus x divided by x. Now let's apply L'Hopital's rule, and we're taking the derivative of the numerator and the denominator. The derivative of the denominator is just going to be 1, so we don't really need that so much. So if you take the derivative of ln of e to the x plus x, that's going to be 1 divided by e to the x plus x times the derivative of that inner function, which is just going to be e to the x plus 1. So I'm going to write it like that. And now let's go ahead and see what we get. Since we have this e to the x, let's apply L'Hopital's rule again. And you do the limit as x approaches infinity. So I'm going to erase this one here. All right. When you take the derivative of the numerator, you're just going to get e to the x. And the derivative of the denominator is going to be e to the x plus 1. And let's do this one more time. So we're going to apply L'Hopital's rule one more time as the limit of x approaching infinity. So you're going to get e to the x divided by e to the x. So when you divide these two, you're just going to get 1. So that's the limit for the limit of ln of y. That's not our limit here. We need the limit of y. We need the limit. This is your y. Oops, let me put this in red. This is your y. But we have the limit of ln of y. So we're going to use this formula and write this as the limit as x approaches infinity of e to the x plus x to the power of 1 divided by x equals the limit of x as x approaches infinity. And now we need y, but we only have ln of y. So to get ln of y, we're going to write this formula here. That's e to the power of ln of y, because e to the power of ln of y equals y, which is what we need. So this is just going to equal e, ln of y we got was 1. So we're going to get e to the first power, which just equals e. And that's it. Thank you. Have a nice day. Bye-bye.